Good evening, everybody. Welcome to another in a series of talks by the AES, or the Audio Engineering Society, here in the UK. And this evening, it's the turn of the Cambridge Committee to organise. Just a couple of admin points before we kick off with the main event. First of all, we have a lot of AES members joining already, so thank you very much. And that's good. But I also notice a number of non-AES members, so I'd just like to put the pitch that please join. The Audio Engineering Society is the worldwide society for anyone working in or an interest in audio engineering technology. This evening's procedure is I'm just going to do a quick introduction to Brian and then hand over to him for the main talk. If you have any questions, please use the Q&A button at the bottom of the Zoom screen and post your questions in there. If we don't have any questions yet, thankfully. If you have any urgent questions, just pop them in there as well. I'll keep an eye on it, and if there's any particular points on a slide that is unclear, I'll try and we can answer those on as we go, but for any other questions, we'll handle those after the talk. And we should be aiming to finish around 8 o'clock this evening, UK time. So without further ado, let me introduce you to our speaker tonight. Brian Moller is a serial entrepreneur and innovator. He's based in Aarhus in Denmark. His first business venture was in the mobile phone space, developing a gaming platform, and that was later acquired by Motorola. Brian then moved into audio and video products, where he got a taste and fell in love with audio as the director of R&D at Bang Olufsen. Following that, he then started up a new company, Dynastrom, focusing on wireless streaming over audio over Wi-Fi. And then in 2017, Dynastrom was acquired by Roku. And tonight he's going to talk about how Roku is developing products for streaming synchronized audio over Wi-Fi, which is a bit of a challenge. And Brian's going to tell us how his team have been overcoming those challenges, some of the pitfalls and some of the techniques that they have developed. So without further ado, let me hand over to Brian and let the talk begin.
Thank you, Neil, and thank you for having me today. I look forward to spend a bit of time with you and present a bit of what Roku is doing around audio and wireless synchronized audio or Wi-Fi. So let's dive in. So I just want to, not everyone is familiar with Roku, so I'm just going to spend just a few minutes on who Roku is, and then dive into audio and Roku, and then some of the technical challenges we're going to talk a bit more about, so streaming audio, Wi-Fi, and then just touch on something that also has to do with the experience on TV related to audio, which is called Roku TV Ready. All right, so just sort of highlights of Roku for those not familiar. It was founded in 2002 by Anthony Wood, who's still the CEO. Has headquarters in San Jose in California and offices in many different places, in Cambridge, of course, as well as in Denmark on the development side. And we've been growing quite fast. So I think the last official number of employees is 1,650. We're a bit more than that now, but that's sort of the number we go by. We are listed on NASDAQ as well, so we're a publicly traded company. I just added a few sort of highlights or milestones. I know these are heavily skewed towards audio, which is why we're here today. So there's been a lot of highlights. I'll just name some of the bigger ones. I think the biggest one, or what sort of kicked off what Roku is today, is sort of the invention of a streaming player, which was the first player that had Netflix on it. That was back in 2008. And the year after, we launched our channel store. And was the basis sort of that Roku's built on. In 2014, we went into TV as well with a partnership with TCL, and have evolved on that. And in 2017 was when Dynastrom was acquired, wireless audio company that I helped start. And that sort of kicked off the audio side of Roku. Same year we went on NASDAQ, another big event, and also that same year we launched our Roku channel, sort of our own content channel, if you want, on Roku. And the year after, we unveiled the first speakers, the wireless speakers that connect sort of wirelessly onto the TV. And the year after that, we had our first sort of smart soundbar, a streamer basically with a soundbar around it, plus a subwoofer that goes with that and also works with our Roku wireless speakers. In 2020, I didn't put that, but we launched Roku TV Ready, as well as launched a new stream bar called, actually it's called Stream Bar. The name I remember is the internal project name, which has some nice beamforming and some other effects to it. And we also just recently announced, or TCL announced, a Roku wireless soundbar, which is our newest product line in our product. So we've been busy developing these products. And as I said, Roku's born out of had this first sort of streaming player with Netflix on it, but we have a whole SKU of different types of streaming products, from a very cheap 2K streaming player to a Roku Ultra, which is sort of on the right side, the black, which has is the most powerful Roku player there is. It has a nice private listening feature when you plug in your headset into the remote, TV mutes, and you get the audio from your remote. So sort of have a scale of products. And just the main difference here also with the streaming products and the TV products is the streaming products are all Roku branded, but the TV are all with partners. So we have a number of partners that are building TVs with our technology inside. So we manage all the software, we do the hardware reference design, and then the TV partners, they build the products and sell them and market them. And we're doing quite well. We've grown quite fast in terms of reach and engagement and scale. And sort of as before we turned to the new year, we had 51 million active accounts, which means there's people that use our platform actively on an active basis. We also have a lot of hours streamed, 17 billion hours streamed in Q4 2020, and that's a lot. Just sort of compared to competitors in US, where US is our main market, although we are about to conquer the world, one country at a time. But if you sort of compare to have an idea of how well we're doing compared to competition, you can have a look at our streamed on Amazon Fire, which is the closest competitor. We streamed 58% more. On Samsung, which is one of the biggest TV manufacturer, you probably know them, 117%, and you can go on. I mean, we are quite big, and you see some of the bigger names out here with Google and their products. We're still quite much larger in US. So we're fighting some big competitors, but we're doing quite well doing so. All right, that's sort of enough of we're pretty big and cool. You should have an idea about that now. But let's get into a bit more audio and what are we doing on that. Well, with every other product with Roku, we try to make things as simple to use as possible. So what we call a premium audio made simple is sort of a term, and you should just be able to connect it. It should set up itself more or less, and then you're flying. And the type of products we built is we have the two first products you see on the left. One is called Stream Bar and Smart Soundbar. They have players built in, so they both have a 4K player also built in, and you can connect multiple speakers to it. I'll show you the configurations we support in a bit. And then you have the Roku wireless speakers. That was the first speakers we built, some nice stereo speakers you just pair with your TV. Sounds awesome. And then our small discrete sub, 10-inch sub, that we built to make sure you get all the oomph you want when you enjoy those new videos and entertainment. All right, yeah, and this is just for those who are interested. You can find more online, but it's just a high-level spec of these products. So the driver configuration, where the two stream bars have full-range speakers or drivers, 2-inch on the left driver, and 2 of those are angled to give some beamforming as well. And then you have so 2.5 full range in the Roku wireless speaker is a sort of tweeter woofer configuration, and the subwoofer is a 10-inch woofer. And in terms of base capability, we use zones to measure and when we define and design our speakers to make sure they sort of follow that scale in terms of price and performance across the board. And here you can also see the max feel and what we sell the products for. So they're, in my opinion, humble opinion, it's awesome products performing quite well. So very proud of building those. And the types of configurations we support right now with them is that on the left, you can, with our stream bars, which can connect to any TV, you can add 2 wireless speakers as surround speakers and add the subwoofer wirelessly. If you have a Roku TV, you can add the stereo pair plus a subwoofer. And as we just announced in 2021, there's going to be a wireless soundbar you can add to it. And we are looking at also expanding these configuration moving forward. There are definitely challenges in creating interchangeable configurations, both from a tuning perspective, but also from a performance perspective. This is sort of the lineup we have right now. Okay, so that was about the products, and now into some of the meat of what the challenges are. I think one of the big challenges when you develop a system like this is latency. Latency matters a lot, and there's latency in terms of AV sync you need to perform to. There's latency for interaction, like gaming, where you have a different requirement on latency and feedback. And then there's latency in terms of inter-channel latency. So how precisely can you have audio-to-audio synchronization? That's sort of the latency part. We can dig into that a bit. But there's latency. Latency can come from many different places. It's algorithmic latency. There's processing latency and also in terms of the content and decoding latencies. There's different types that can contribute to that. On Wi-Fi, which can be relatively unpredictable sometimes in its behavior. The quality, the signal quality, signal to noise ratio, the bandwidth, the congestion, also all of it plays a role and interference in terms of how easy it is to make these systems perform well. And we'll dig into that a bit as well. And on the audio quality, I termed that as, I mean, there's different things that interfere with that as well. I mean, there's a codec, you can choose what type of content you're decoding, how hard you compress it. There's different algorithm optimizations you can do where you often do trade-offs between sort of quality, how precise it's going to be versus the time you have to do it and versus the CPU load. Our products, we try to keep them alive for many years, where we continuously update the products, and some of the older products do not have a lot of memory or CPU power. So we try to always write code that does not require a lot of CPU computation power or a lot of memory as well. Oops. All right, and in terms of latency, if we dig into that a bit, I mean, for AV sync, we used an old ITU standard that might be familiar with, where basically it's I think it's all back from when you had what's it called, tubes TV. I can't remember what they're called now, CRT type TVs, and And they made some measurements to figure out when is the lip sync detectable or undetectable, and when is it annoying. And from this, it's if you're below 100 milliseconds late with the audio, you should be okay from a sort of experience perspective. If you're ahead of the video, that's worse. You can't be more than 20 milliseconds ahead, and it starts to be detectable and annoying for some people. So we kind of use that as a measuring stick to say, is it acceptable what we're presenting to the user? However, that doesn't work for things like gaming, or when you need an immediate feedback on what you're doing. And for that, I mean, we have an option where, so if we have wireless speakers connected to a TV and we recognize we cannot provide a good enough service or fast enough feedback because of Wi-Fi issues or whatnot, there's an option for the user to decide whether or not they want to listen to the audio through the TV. So that's something we realize in some environments that's just too hard, or you'd have too many dropouts and it's going to sound awful for you. So that's some of the things that you want to consider when you build these type of systems. Another thing that was important for us is that we built our own DSP portfolio. And we basically did that to ensure we have full control over the audio pipeline and know every single step and can optimize the entire audio pipeline as well. Because as I was saying, finding the optimum is a compromise. Oops, sorry. It's a compromise between latency, processing load, and also whether or not how good your Wi-Fi is, and what level of audio quality you want to provide for the user. There's a list of things we support as well, and we look at these algorithms on a continuous basis to make sure if we can find optimizations that can help us or fine-tune them to make them even better. And one example of stuff we've done as well is that we use a Opus as a sort of a free open codec. We use that as an internal format when we distribute audio across multiple products. And that supports variable bit rates, and it supports different levels of complexity and different levels of compression. And we did a lot of tests to find out what is acceptable or what is perceptible in terms of quality of audio that gives you sort of the premium between getting a good audio quality in terms of good latency, no dropouts, and in terms of perceived quality. So we did some listening tests on different things using the peak algorithm to find out that optimum. So we spent quite some time on that. If you had enough time, and if there's actually also some things you can do differently. If you're streaming and you're in control of the source, then you can go with a higher bit rate. You can go with a higher quality. You can do a lot of things. But if you're not, if you're on an ARC input from a TV and your soundbar, you just get the data and you just have to shift it as fast as possible. There's no way you can do any tricks like delaying video or to enable to synchronize it. So yeah, and another latency thing is Wi-Fi. I mean, Wi-Fi has its own life sometimes in terms of how it behaves and what the latency is. And what we looked at here on the left is that when can we assure that all packets have reached the receiver? And these are different type of products and Wi-Fi radios, and they behave a bit differently. Also behave differently in hostile environments. And we want to make sure that I mean these are products that we build for mass market. Is return rates is a killer if you get that. So we want to make sure that you have very high satisfaction in terms of performance for the end user. So we set some different KPIs and targets for what is reasonable for 95% of the time, for 95 or 100% of the population of the people who have it. And it's different when you're a TV where we control the OS. So when you have a possibility to do video buffering, that helps a lot compared to if you're a soundbar on an ARC input and you have no control of what's going on. The TV just receive audio. So we designed different solutions for these two different types of scenarios. Can't remember if I had that, but that's where we have different streaming strategies and different Wi-Fi strategies depending on these scenarios. Then there's another issue of audio quality is sort of packet loss. What's the perception and cure for these type of things? And we spent some time investigating what's audible, what's an audible packet loss. If you lose a packet signal of 10 milliseconds in a random session, it's very difficult to notice. If you have 2 of those within 30 milliseconds, though, then you start noticing it. And 12 milliseconds is bad. So there's different patterns of sort of packet loss that means different things in terms of perception. And there's if you have time enough, you can retransmit. You can do FSC. You can do different strategies depending on the time you have available. But you still need to understand what experience did the end user have, or does the end user have. So we use these different investigations to characterize a quality of experience for a user, and we measure that 24/7, but and also in the field as well as in our labs. Of course, then there's the some of the more traditional understanding of audio quality is that we design, of course, our speakers, we tune them and test them, and one of the tools that we're using is sort of near field scanner, where we measure all the different prototypes and have a sort of mathematical models where in 3D where we can manipulate different filters, we can do some of the tuning and try to predict also how the speaker will behave. And that helps us do fast iterations, and we get the type of performance and beamforming that we're interested in. So these are some of the methods that we use also on the sort of non-Wi-Fi perceived audio quality. And then we test as well. So once we built the product, we also test if it actually hit the performance mark that we're trying to achieve. So this is just an example of some data on a blind listening test where we build the product and say, okay, we want to perform better than a Bose Solar 5, and we want to hit this price point. So we did some blind listening tests to see, okay, how well are we doing compared to these type of products. And we did quite well, even though some of the products we're comparing it to include a subwoofer. So these are also some of the data we use on audio quality or performance as well. We're doing it time. All right. And then we have audio sync. So audio synchronization or interchannel delay, if you want, also plays a role on how you perceive the audio quality of your experience. And sort of as a rule of thumb, we used 100 microseconds as sort of the interchannel delay we think is acceptable for stereo type setup or for in a 5x1 setup between the different speakers. And we actually found out that, so we built systems that are even much better than that, and also some systems that are where we had up to 1 millisecond. And one thing we found out is that it's maybe in object noise it's different in Atmos type things, but actually we found that that wasn't the most critical part. The most critical part was actually how stable you can keep that synchronization. So we have our KPI is 100 microseconds. We need to stay below that. But what we found matters more is the adjustments that you make. So you have all kinds of drift in a system like that when you do it over Wi-Fi. So we keep an eye on if they drift too far apart, and then we adjust it. And we did some tests also to figure out how hard can we adjust it, or how fast can we adjust it. So that's also plays into how well this system behaves. So we have some very minor adjustments that we do, are very, very slow adjustments. We can also adjust when there's no audio, then you don't have the issue if you need to do a bigger adjustment. But we did some at different hertz. We measured and did listening tests to figure out what's really acceptable for user, where you can't feel the soundstage slide or move, or get other type of artifacts. So we spent quite some time on that as well. And as I was saying, we measure a lot on 24/7. So we built different automated test setups where we test pairing. Pairing is part of the experience that's easy and works well. And we have these nice boards at the right. We call them space because they give us space. Because when we lay out the speakers as these flat structures, and we can actually put them on top of each other, they don't take up as much space on your desk. And also in our Wi-Fi chambers, when we set it up, you can have a lot of different setups. And we do all kinds of KPI tests, dropouts, AA sync, AV sync, and also a DSP verification and whatnot. So that's some of the stuff that we actually do in our labs. We have some quite big Wi-Fi chambers that we have these systems in, and we can also spam a Wi-Fi to see how it behaves. But actually, we found it's difficult to predict how things behave in life, in real life settings compared to the lab. So even though we run certain tests in our labs, before we have 10, 20, 50,000 users in the field, some issues, they don't show up, or we have difficulties reproducing it until we see them in the field. So there's always a bit nerve-wracking when we add some of this functionality and start rolling it out into real users. All right, you're almost done listening to the presentation. Last thing I'm going to touch on is Roku TV Ready. So we actually also care about other soundbars besides our own, how they work with our TV. So we have a program we introduced, we call Roku TV Ready. And one of the things we do is that we communicate the audio settings from the soundbar with the TV over HDMI, so using CC, so that you can keep one remote when you change sound settings on your soundbar when you're watching TV. You can still do that without having to find the other remote, switching back and forwards. And we make it also super simple to set up when you connect on HDMI. It recognizes the brand, it recognizes the product, and shows you that in your setup. And we have a sort of a growing number of partners that are introducing that. So if you're building a soundbar and you want it to work well in the US, I think you should talk to us, and we can help you at least make it work well for Roku TVs. All right, that's enough for me talking.
Thank you very much, Brian. Thank you to everybody attending. It's just coming up to not quite 8 o'clock, so time for a cup of tea. Thank you very much, and good night.
All right, good night.